So this is a video produced for Eric to demonstrate the dimensions of the primary winding of this resonant transformer. This resonant transformer, we call it the Tonopah East coil because it was modeled after a coil winding that Eric has in his lab out in Tonopah. It's pretty much accurate, with the exception that the number of turns on that secondary coil are one additional turn to the coil in place out at Tonopah. So our focus today is on the primary winding in hopes that the construction of one can be adopted to the Tonopah coil, since they've only been series feeding it with a current transformer made of ferrite, which is very lossy. This method, by utilizing the primary 3 turns spaced at a specific distance down from the secondary, will loosely couple very efficiently very large quantities of energy into the secondary, and the secondary is allowed to freely resonate to a high degree with minimal overcoupling from the primary, which results in a very pure single hump resonance. There is no parallel resonance that is apparent. It is a series resonant point. High current in the ground connection, high potential at the elevated capacity. So the setup here, I've adjusted this to be at the point of resonance that Eric's interested in. It's up around 2 megacycles. And I've adjusted the parameters here, those being the position of the elevated capacity and the primary winding separation from the secondary. So I did that up on the roof here of the arch, where the coil has been installed here for, I don't know, 6 or 7 months now, and it's been exposed to the elements, and it hasn't been affected poorly at all. With the oxidization of the exposed copper capacitance ring and the copper primary windings, as well as the gradient turns that has raw copper exposed to the elements. And when it gets wet, yes, it will affect the tuning, but in all dry conditions, it comes right back to where it has been set. So just to set it up at the frequency, what I've done is come up here with an analyzer and disconnected the feed that goes down to the operating position down inside the arch here. And I've connected via a piece of coax coming down from the secondary winding, coming across the roof to this, I'm using this adjustable balun, which is a very unique design unto itself, just to decouple any stray common mode currents from the analyzer. So I don't know if I can get a clear shot. There we go. There's all the parameters right now. Get a little closer. So you can see that the impedance is about 33 ohms, and it's at resonance with a standing wave ratio of about 1.84. Now that could be fine-tuned a little bit by adjusting the primary to the secondary distance. You could probably get it down a little lower, but it's close enough for experimental purposes. So I'll take you over and show you the dimensions. Let me see if I can stand up. I've been kneeling down here for a while and just turning 70 years old. It's a little creaky. The knees, that is. So let me see if I can pan out a little. Now the primary is what you're interested in. So stretching out the ruler, measuring down from the bottom turn of the secondary, you're looking at approximately 11 3/4 inches down from the bottom turn of the secondary, and approximately maybe 8.5 inches down from the lower gradient ring. Now this is set up pretty much identical in terms of the gradient rings and the windings to the Tonopah coil. The 3-turn primary is made up of Heliax hardline, 2 inches, 1/2 inch diameter, 3 turns, wound in the same direction as the secondary. What I've used here for the capacity hat, and I know you've got a different arrangement out there, is just a 1-inch piece of Heliax, which has been stripped of its plastic installation and soldered and formed into a ring. It has an adjustable set screw over there, where I can loosen it and slide it up and down on this fiberglass center mast. And so if I raise this, I can cover pretty much the entire 160 meter band within this range here. And right now it's at 2 megacycles. So that dimension there is about bottom of the cap ring to the top of the gradient ring is a little under 9 inches. This is, like I say, 1 inch in diameter, and let me see, it's about 29 inches across, which is about the diameter here. And another difference between the Tonopah coil is that I've used flat copper, oxygen-free copper magnet wire, and you guys used I don't know, some brake line or something. I remember it was copper tubing, 1/4 inch. These slots are 1/4 inch, and the spacing here, as near as I could figure out from all the information I got from out west, is as accurate as I can get to match the coil you guys have. So you're looking at 1 1/8 inches spacing, and all the other diameters, gradient rings to the top turn, and gradient ring to the bottom trim. Those have all been held to the standards that you created. So there's the setup. I hope this helps. I'll get this up so you guys can see it. And good luck out there setting up the beacon. I'll be listening for it.